On June 22, 1893, the Mediterranean fleet was on maneuvers off Tripoli. The flagship HMS Victoria, a 10,000-ton ironclad with the heaviest guns in the Royal Navy, steamed at full speed in tight formation. Vice Admiral Tryon gave an order. His subordinates knew it was impossible. They questioned it. He repeated it. 8 minutes later, Victoria was underwater. 358 men went down with her. The ship's own rambow, a deliberate design choice, had been driven into her hull by another British battleship. The flaw wasn't a hidden crack or a material failure. It was built into the blueprint, signed off, and celebrated. And it is far from the only time a warship's design killed its own crew. What does it feel like to stand on a deck that is actively working against you, to realize the very shape of the hull beneath your feet has already decided your fate? How many of these disasters were not accidents at all, but predictable physics set in motion by a single fatal decision at the drawing board? Today, 10 naval catastrophes where the design was the disaster, starting with the ship that was too heavy to float. HMS Victoria, 1887, the largest, fastest, and most powerful ironclad afloat when she launched, a flagship of the Mediterranean fleet and a ship with a fatal geometry problem. Her main armament was a single turret mounted on the low forward deck, housing two massive BL 16.25-inch guns. The guns were so heavy that their barrels drooped on the mountings and could fire only 75 rounds before the barrel wear became excessive. The great weight of this forward turret forced it to be mounted extremely low to maintain stability, which meant her foredeck was barely above the waterline. In anything but a flat calm, the sea washed over it, earning her the nickname the Slipper because the deck simply disappeared from view. This low bow, combined with a raised aft superstructure, created a bizarre and unbalanced silhouette. On June 22, 1893, during fleet maneuvers off Tripoli, Admiral Sir George Tryon ordered his two columns of ships to turn towards each other. They were steaming in parallel lines, just 1,200 yards apart. The minimum turning circle for these battleships was at least 1,600 yards. The math was impossible. The flagship Victoria, leading one column, turned directly into the path of HMS Camperdown. Camperdown's armored ram tore into Victoria's side. The ship capsized and sank in roughly 15 minutes. 358 men died, including Admiral Tryon. One survivor was her executive officer, John Jellicoe. The wreck was found in 2004, standing vertically on the seabed, her bow buried deep in the mud, driven down by the weight of that enormous forward turret and her still turning propellers. A flagship destroyed by an order that defied the physics of her own turning circle. But a simple miscalculation of distance is one thing. A disaster born from a fundamental instability that turned a passenger steamer into a death trap on a calm city river is quite another. SS Eastland, July 24, 1915, a damp Saturday morning in Chicago. The ship was tied to a dock in the Chicago River, packed with 2,500 Western Electric employees and their families headed for a company picnic. By 7:28 a.m., she was lying on her side in 20 feet of water. Yet 844 people died, trapped inside or crushed beneath her hull. The disaster was not a collision. It was not a storm. The Eastland was killed by a fatal design flaw that was compounded over 12 years of modifications. The core problem was stability. A ship's stability is defined by its metacentric height, a measure of how strongly it resists rolling. A high metacentric height means sharp, violent snaps back to center. A low metacentric height means the ship rolls slowly and can capsize. And if that center of mass is too high, the ship becomes fundamentally unstable. The Eastland was designed with a low metacentric height to begin with. Then, in 1903, to increase her speed and fix a draft issue, her owners returned her to the shipyard. They added an induced draft system for the boilers and repositioned machinery to reduce the hull draft. This raised the center of gravity and cut the ship's original stability margin. Listings began immediately. She nearly capsized in July 1904 with 3,000 passengers aboard. The response was not to fix the ballast deep in the hull, but to remove cabins and add lifeboats up high. Then the concrete came. In 1914, the forward dining room's hardwood floor was torn out and replaced with 2 inches of concrete. The aft gangway got another layer, 15 to 20 tons of solid mass, all placed on the cabin level, well above the water line. The ship was already tender, prone to listing. The final shove came from Washington. After the Titanic sank, the Seamen's Act of 1915 mandated enough lifeboats for every soul on board. The Eastland's owners added a full complement of heavy wooden lifeboats and davits to the top deck to qualify for a 2,500 passenger license. On the morning of the disaster, the ship was packed and top-heavy. A slight port list began. The crew flooded ballast tanks to correct it, but water, sloshing, free surface, and partially filled tanks only worsened the roll. Within minutes, the Eastland lurched sharply to port and simply lay down on the river bottom. 844 people perished inside a ship that never left the dock. She was later raised, rebuilt as a Navy gunboat, and served through World War II. But on that morning, a decade of piled-up top weight finally beat the river. A ship lost to gravity. But a different miscalculation years earlier saw a revolutionary battleship vanish completely in a gale. A ship whose designer literally mounted fortress-sized gun turrets on a hull never meant to hold them. HMS Captain, 1869. In the late 1860s, the British Admiralty faced a fierce public campaign by Captain Cowper Coles, the inventor of the rotating gun turret. Coles had proven his concept on coastal vessels, but he was now enraged that the Navy's new ocean-going turret ship, HMS Monarch, did not match his vision. After a parliamentary and press firestorm, the Admiralty relented. They let Coles build his own perfect, sea-going turret ship. The result was a radical warship with 2 revolving gun turrets on a hull designed to sit just 8 feet above the water. The problem was not the turrets themselves. The fatal flaw was a catastrophic combination of a dangerously low freeboard and an immense spread of sail. Coles insisted on a full ship rig over 27,000 square feet of canvas to make the vessel ocean-going. All that sail area was mounted high up on tripod masts and a hurricane deck above the turrets. This placed an enormous weight aloft, raising the ship's center of gravity dramatically. Meanwhile, the hull sat so low in the water that waves could wash right over the deck. The 2 flaws fed each other. When the ship heeled under wind, the low freeboard failed to provide the buoyant counterpush that keeps a vessel upright. Instead, the deep hull simply dug in, and the towering weight of the rigging pushed her further over. During construction, things got worse. Coles fell seriously ill, and a lax supervision allowed the builders to add over 735 long tons of extra weight. The ship floated 22 inches deeper than designed. The promised 8-foot freeboard shrank to just 6 feet 6 inches. The center of gravity rose even higher. The chief constructor, Edward Reed, protested furiously, warning that the ship would be unstable under sail. His objections were overruled. In September 1870, just 5 months after commissioning, HMS Captain joined the Mediterranean fleet off Cape Finisterre. She was running under sail in a rising gale, making nearly 12 knots. As the wind strengthened, the ship began to roll heavily. Admiral Sir Alexander Milne, watching from on board, saw waves flooding the weather deck. He departed, and hours later, a violent squall hit. The captain heeled over, her low freeboard submerged, and the weight of the rigging took over. She capsized in seconds. 480 men drowned. Coles himself went down with his creation. The Admiralty buried the disaster and never again let a private designer dictate a warship's stability. But the ocean had an even stranger way of punishing a flawed hull. Japanese cruiser Onebi. In the mid-1880s, the Imperial Japanese Navy was in a frantic arms race, desperate to match the Chinese Beiyang fleet. Unable to build large warships themselves, they turned to Europe. The British built them the fast, modern Naniwa class. For a third ship, they went to France. The contract was signed with Forges et Chantiers de la Méditerranée in May 1884. The result was a disaster etched into naval history. The core flaw was a lethal instability, a top-heavy design that made the ship a death trap in anything but a flat calm. The French yard gave Onebi a massive armament for her size. 4 24-centimeter Krupp guns mounted high on sponsons, plus 7 15-centimeter guns on the upper deck. This enormous weight was concentrated far above the waterline. To make matters worse, the hull had an extreme tumble home. The sides sloped inward sharply, which saved weight, but catastrophically reduced the ship's riding force. Her metacentric height was never officially measured, but it was believed to be dangerously low. The physical consequence was immediate and terrifying. On her delivery voyage from France, she ran into a storm. The ship rolled so violently, her survival was at risk, forcing her back to port. She tried again, and in the Mediterranean, another storm forced her to offload 2 of her main guns in Aden just to stay upright. She limped into Singapore, departed for Tokyo Bay on December 3, 1886, and vanished. No distress call, no witnesses. The ship simply capsized in a typhoon. The top-heavy design sending her and all 174 men to the bottom in minutes. A decade later, wreckage with her name washed up on a remote island. The Japanese Navy quietly struck her from the list and never ordered a French warship again. The insurance money went to a British yard. A top-heavy cruiser swallowed by the sea was a disaster, but what comes next is a ship that was born to spin. A Russian monitor Novgorod. In 1874, the Imperial Russian Navy commissioned a warship shaped like a soup bowl. The man responsible was Rear Admiral Andrei Popov, who took a theory about wide-beamed ships and pushed it to its logical, disastrous extreme. He made the hull completely circular. The idea was seductive. A round ship, 101 feet in diameter, displacing 2,491 tons, could carry 12 inches of wrought iron armor and a pair of massive 11-inch rifled guns on a draft of just 13.5 feet. Shallow enough for the river estuaries and coastal waters it was meant to defend. The fatal flaw was not the guns, the armor, or the draft. It was the water. A circular hull is a hydrodynamic nightmare. The blunt form created so much turbulent drag that the rudder was starved of clean water flow, rendering it almost useless. The ship took an agonizing 40 to 45 minutes to complete a full turn. In a severe storm, it became completely unsteerable, losing all headway in a force 8 gale. The only way to change direction was by running the 6 propellers at different speeds, which further crippled its already abysmal top speed of 6.5 knots. It was slow, it guzzled coal, and the 800-yard firing range of its colossal guns was pointless if the ship couldn't pivot to face a moving target. The real killer, however, was the persistent myth that firing its guns would spin the whole vessel uncontrollably. The myth was false, but it perfectly captured the project's absurdity. A design born from a clever math problem. Shipwrecked by the simple physics of a flowing river, Novgorod spent its career as a sluggish coastal guard, never once firing its guns in anger, and was scrapped in 1911. The Popovka was a lesson in hubris on the water, but France was about to launch a lesson in hubris beneath it. French submarine Surcouf. Launched in 1929, she was a direct response to the Washington Naval Treaty. The treaty capped battleship guns, but left submarine armament almost untouched. France exploited this loophole and built an underwater cruiser with a twin turret housing 2 203mm guns. The turret was pressure-tight, designed to seal out the ocean. It never worked properly. The seals leaked constantly, allowing seawater to seep into the turret mechanism and corrode the bearings. Any dive put the guns at risk. Surfacing and preparing to fire was a slow, deliberate chore. The crew needed 3.5 minutes to get the first round off, and only if the boat surfaced level. Training the turret was impossible if the ship rolled more than 8 degrees. Even at the rangefinder's maximum visible horizon of 11 kilometers, the guns could not reach their theoretical range without the spotter float plane. The plane, stored in a watertight hangar, had to be assembled on deck before launch, a procedure impossible in any real combat scenario. The boat was blind at night, unable to observe shot fall. Surcouf demanded a crew of up to 130 men, triple that of an ordinary submarine, turning simple operations into a personnel crisis. She vanished on the night of February 18, 1942 in the Caribbean. The most accepted theory is a collision with the American freighter Thomson Lakes. No distress signal was heard. 130 men went down in a submarine whose main weapon could barely be used, but as clumsy as a submerged gun platform was, it still had a single hull. The next disaster ignored the sea entirely. A warship that tried to sail through the sky. USS Macon, ZRS-5. Launched in 1933, this was one of the largest helium-filled rigid airships ever built, a flying aircraft carrier designed to scout for the fleet. Inside its massive duralumin hull, a trapeze system deployed and recovered up to 5 Curtiss F-9C Sparrowhawk biplanes. The core design flaw was a structural vulnerability at the tail. The upper tail fin attached to a specific frame ring, number 17.5, which was not adequately reinforced to handle the aerodynamic stress of the ship's own powerful maneuvers. In turbulent air, the entire fin acted like a giant lever, concentrating twisting forces on that single, unreinforced joint. The problem was known. During a cross-country flight in April 1934, severe turbulence over Texas snapped the diagonal girders at that exact frame. The crew made emergency repairs, but permanent reinforcement with duralumin channels was deemed unnecessary and never completed. The airship kept flying. On February 12, 1935, returning from fleet maneuvers, Macon flew into a storm off Point Sur, California. A sudden wind shear hit the ship, and the unstrengthened frame 17.5 failed catastrophically. The upper fin tore away, ripping open the rear gas cells. The tail dropped, the ship nosed up past its pressure height of 2,800 feet, and helium vented uncontrollably. It took 20 minutes to settle into the sea. 64 men were rescued thanks to new life jackets and rafts, but 2 were lost. Macon sank, and the Navy's vision of a flying aircraft carrier sank with it. But the pursuit of impossible fleet coordination spawned an even more absurd underwater counterpart. K-class submarine, UK. In 1913, the Royal Navy envisioned a submarine that could keep pace with the battle fleet, sweeping ahead at 24 knots. The only way to achieve that speed was steam turbines. Admiral Jackie Fisher called it the most fatal error imaginable, putting steam engines in a submarine. The K-class needed massive boiler rooms, air intakes, and twin funnels that had to be folded down and sealed before diving. The procedure took at least 5 minutes, under emergency conditions. In a heavy storm, seawater could pour down those funnels and extinguish the boiler fires. The hole stretched 339 feet, longer than the safe diving depth of 200 feet. Even a 10-degree angle created a 59-foot difference between bow and stern, making depth control a nightmare. The internal bulkheads could withstand pressure equivalent to only 70 feet, so any hull breach at depth meant catastrophic collapse. The result was a litany of disasters. K-13 sank on trials when an intake failed to close. K-1 collided with K-4 and was scuttled. During the Battle of May Island in 1918, a cruiser rammed K-17, which sank in 8 minutes. K-4 was cut in half by K-6, then struck by K-7, killing all aboard. In just 75 minutes, 2 submarines were lost and 3 damaged. Not one K-class boat was destroyed by enemy action, but 6 sank in accidents. The steam submarine was a death trap, yet the next disaster involved a vessel so vast and so poorly protected that it would sink just 10 days after commissioning, without ever firing a shot. Japanese aircraft carrier Shinano. In November 1944, the Imperial Japanese Navy faced a desperate situation. The largest aircraft carrier ever built, a converted Yamato-class battleship displacing 73,000 metric tons at full load, was in danger at Yokosuka. American B-29. Superfortress reconnaissance planes had photographed the ship. Fearing air raids, Naval Command ordered her to move to Kure Naval Base for final fitting out. She departed on November 28th, just 10 days after commissioning. She never arrived. Her fatal flaw was not the 4 torpedoes that struck her. It was the state of her internal compartments. Shinano was rushed out of dry dock with her conversion incomplete. The vast majority of her watertight doors had not been installed. Critical openings for ventilation ducts, cable runs, and piping remained unsealed throughout the hull. When the submarine Archerfish put 4 torpedoes into her starboard side, water did not simply flood a few damaged sections. It cascaded through these open passages, spreading freely from compartment to compartment with no physical barrier to stop it. The situation was made worse by a complete absence of damage control capability. The ship had no pumps installed in her watertight spaces. Her crew of 2,400 officers and men had never conducted a single damage control drill. Many were civilian shipyard workers who had come aboard just to finish the voyage. When the flooding began, progressive and unstoppable, the men on board had neither the equipment nor the training to fight it. The largest warship ever sunk by a submarine took 1,435 men with her. Captain Toshio Abe went down with his ship, a 72,000-ton carrier undone by open hatches and missing pumps. But the disaster waiting under our next number was even more fundamental. A warship that could not even survive a harbor breeze. Vasa, in 1628, Sweden was fighting a war with Poland, Lithuania, and King Gustavus Adolphus needed warships. He needed them to project power, and he needed them immediately. The king personally approved the dimensions for a new kind of vessel, one with 2 full gun decks, a floating fortress bristling with 64 bronze cannons. The problem was the hull. The shipwright, a Dutchman named Henrik Hubertson, had never built a ship with 2 gun decks before. He lacked the calculations, the established ratios. He simply scaled up a smaller design, making the hull exceptionally narrow for its height. The underwater part of the hull was too small and too shallow to hold enough stone ballast to counter the immense weight of the upper structure, the massive oak timbers, and those heavy guns sitting high above the waterline. The ship's center of gravity was fatally high. Before the maiden voyage on August 10th, the captain demonstrated the instability. 30 men ran back and forth across the deck. The ship heeled so violently he had to stop the test, fearing it would capsize right there at the quay. But the king was in Poland, demanding his new flagship join the fleet. His subordinates lacked the political courage to stop the launch. Vasa sailed less than a mile. A light gust caught her sails, and she rolled over in Stockholm harbor. Water poured through the open lower gun ports. She sank in minutes, taking 30 people with her. The ship that was supposed to be the most powerful in the world could not survive its first encounter with a breeze. An inquiry found no one guilty, and the disaster was quietly blamed on the dead designer. For 333 years, Vasa sat in the mud, a perfectly preserved monument to the simple, lethal math of top weight. A warship is a floating compromise, and the sea has no patience for bad math. If you enjoyed this video, leave a like and subscribe to the channel. Drop your idea for the next episode in the comments.